Speaking. I'm a landowner in central Mississippi, Sunflower County, kind of the center of the bullseye for the aquifer issues, and we've been actively involved in some of the natural resource conservation services programs because they are well funded in our county. They're not everywhere, and they're not focused on these issues everywhere, but they are where we are, and they've made a great partner to us over a period of years. So that's part of what I want to relate and talk about what it's like as a landowner to go through, I guess we're about 10 or 12 years into it, to put some reservoirs in, own farm water storage stuff, tailwater recoveries, and we're in a lot of the NRCS programs. And how is it? Why would you want to do it? How do you do it? What are the values of having done so? What are some of the challenges of doing that? That's the focus that I will bring. And a lot of the systems, once they're put in, a lot of it involves moving dirt. And just like you can go to Vicksburg and see the trenches from the Civil War they dug with little shovels. Once you move dirt, it stays moved. So a lot of the improvements that are going in place right now are semi-permanent. And in that sense, I've likened this whole effort. I really look at it almost, if it were done on a grander scale, is like building out the interstate highway system in the 50s. We're building out a farming infrastructure now that is near permanent. It changes your yields in terms of reliability, in terms of size of your yields. It changes the math on your farm in terms of profitability. It changes your yields, it changes your rent, it changes your land values. It also, the focus of course up to now has been about conservation. And the old adage of, if you take care of the land will take care of you. All that NRCS's mission statement, I think, is helping people help the land. Those things come together in a sort of uncanny way. Normally, if you're trying to do the most environmentally correct thing, you're going to give up quality or you're going to pay a higher price. And it's not working out that way in the farm environment at all. If you started out as a landowner and you say, I'm just greedy as hell and I want to make the most money I can, you'd probably design the same thing that NRCS is designing. So it's really interesting how it works out. They're very focused, as Mary Love said, on preventing nitrogen from flowing down into the Gulf of Mexico, because there's a 5,000 square mile dead zone there. And their funding is hinged on that, because when they get in agricultural trade negotiations with the Europeans and others, they don't want to say we're subsidizing farmers to get them where they can raise bigger crops. No, they say we're addressing an environmental catastrophe in the Gulf. It just works out that it helps them grow bigger crops. So that convergence of interests makes for really sort of strange bedfellows in a way, but it really has worked out in a surprising and good way. And I'm not even looking at my slides, but this is, I stole a slide from Mary Love. This is as she showed earlier, it shows a tailwater and it shows a reservoir. Sort of on either side of this, landform fields themselves, the larger system that's being built out is when you put pads around a field and you precision level at 1/10 or whatever your fall is, you're controlling how the water is leaving the field. So it doesn't take as much sediment. Most of the things are going to settle out, but it's still going to get out. But there are pads around it, and there's a control point for the exit of the water, and that control point is a traditional flashboard riser in the Delta. It's a device that goes on the drain pipe at the feet into the field, and you just stack boards up in it. I'm assuming most people are familiar with them. It does two things. You can adjust your water level, and then the water's leaving over the top. If it's leaving over the top, that's a settling pond. That top inch is all that's getting out of there. So that is a one-trick pony for NRCS, because they do that over and over. The tailwaters are another settling pond. The reservoirs are a settling pond. The check dams and the ditches after it gets out of there, all variations on a theme. It's settling out nitrogen, topsoil, fungicides, herbicides, all the things they don't want to see downstream. And farmers paid a lot of money for nitrogen in particular, and you didn't buy it to run it downstream. So there's a convergence of interest there as well. So that's one side of it. You pick up your fields themselves, you put in behind them the tailwaters, then the reservoirs, then the check dams, and then you've got the low water weirs built into your tailwaters. And then on the next side of that is automation, which we're already seeing. These systems work really well, but in some ways they put more work on the farmer. And there's no data or information provided back to NRCS. It's spending a ton of money to get this stuff done. So there's a need, and there's already a presence of automation of these systems, which is the next shoe to fall. I'm a landowner, but I think it said on my first slide something about AutoFlow LC. It's an automated flashboard riser. that we're coming out with. It's a internet-controlled device that replaces the woodboard riser that has a water level sensor and a gate position sensor, and we're putting nitrogen, continuous monitoring sensors in them for nitrogen and other stuff because it's the key point for where the water leaves. And then it can potentially become part of a larger semi-autonomous irrigation management system, which is where I think things, for a lot of reasons, are going. NRCS needs it, and the farmers need it too. So, not getting to my slides very quickly here. What you get out of these integrated systems, a lot of stuff we've already talked about, reduction in downstream contaminants. You can get efficient application of the water to the root zone when you landform, put pads around it, so you're not going to need to use as much water as you would if you had hills and hollers in your field. You're going to do a better job. And you can impound water in the winter months. That's all the, it's going to promote the recharge of the aquifer. That's sort of NRCS's reason for being in this thing in part. And then the farmer is probably looking at more about, I want water when I want it, and I want it there conveniently and in sufficient volume. I want it to go on uniformly. I want it to apply efficiently, and I don't want to send my nitrogen downstream. Talked about this a little bit already. I got ahead of myself. The benefits of all of this from the farmer's perspective, kind of a combined perspective really. Larger yields are going to drive higher rents, are going to drive higher land values. That's all good. Reduced irrigation management costs. As you drive to these things, you reduce in labor, materials, energy, long-term sustainability. You take care of the land, it'll take care of you. It's no good. Land's not cheap anymore. The cut and run farming days is long gone. So we need to attend to what we have. Water quality goes up, other benefits. This is our farm. I'm going to blast through this fairly quickly. This is about 10 or 12 years ago, 1904, cultivatable acres, 2,100 roughly total acres, none of it optimized for farming, none of it optimized for wildlife, and no water storage. And now those three things are the three jobs that are available on my farm for every acre. You're either farming the best you can farm, you're growing wildlife for me, or you're holding water for my farming. Every acre is I'm looking for them to do that. We started with a blank slate, which is, it turns out it's kind of a good thing. We didn't have a lot of improvements in the way, and we ended up with about 32,000 feet of underground line, 2 reservoirs. I'm going to detail some of that. I'll get through it because it's particular to me, but the gist of it is we've done a lot of fixing up, and we've had a lot of help and expertise, on-site, engineers coming in and helping us design our systems, and it's been hugely beneficial, and of course cost sharing. And the landowner is contributing a lot to that too, permanently contributing acres if nothing else. And this is the south part of my place. That's a reservoir that we're now connecting to the Sunflower River. We're in mid-project on that. This is a reservoir that combos up as a really good bass lake. It's 19 feet deep, and it's turned into a fantastic bass lake. These are the blue dots are wells. The green dots are surface water pumps, and if you turn that pump on, it'll come out down here. It's all one system. So we can turn on 2 or 3 water sources and open up 4 or 5 water outlets simultaneously and balance them, and we've loved that part of it. We've got a reservoir that will go in here next, and we'll landform that piece. It was for wildlife, but it's too close to a road, so we're going to turn it into another reservoir. So, and all of that is precision, though, except that's wildlife. And then the next slide is the north half of the place, more the same. This is a dedicated wildlife area with engineered duck holes. We've got 6, I think, fully engineered duck holes from the biologist NRCS provided, did a great job. And this is a 3/4 of a mile long tailwater, and it connects to a ditch that I think is 3 miles long, and we impound water in the whole thing. So at the end of this 3-month drought that we just finished, we were full. All our surface water was full. And part of the reason for that is, God bless them, my catfish neighbors. They flush like crazy all during the hottest months, so we cheat a little bit that we have that. Not everybody has that, but we hope the river, if they ever go away, we hope that river project on the south end of the place would give us year-round availability. Anywhere that we have surface water, we didn't turn on our well. We raised a crop this year. We got a rain twice, 1/10, 2 times, and we raised a really great crop. All with anywhere we can touch surface water, which up here we cannot. We're going to be working on that, but anywhere surface water was available, the farmer preferred it. We put the water in the reservoirs, he takes it out. I'm the landowner, I'm not the farmer. I want to make it where he'll use the system. No thermal shock, greater flows. He gets a great, a lot of our stuff is plumbed twice. You can get it out of a well and out of a surface water source simultaneously. If we're doing rice, you can really get the water on the field quick. They love it. They've used it, and it's really been, the surface water is a better deal for the farmer as long as we fill the reservoir up. If the farmer's got to fill it up, they just turn well. And here's some sort of before and after, and I'll go through this quickly, but the gist of it is we landformed up pretty much our whole place. We've got 12 wells. We replaced the 6 that were there, were all 30 years old. So we ended up with 12 wells, 6 of them electric, 6 of them diesel still. We're trying to convert them all to electric with further shaft motors because we're going to automation is what we want to do. We got 7 surface water pumps, 13 flow meters. We want flow meters on everything. I want to know what part of our crop is being raised with surface water and what part of it's being raised with groundwater. I just want to know. And so we've set up with the river pump and we're getting the automation in place. This is all the underground line we had when we started, and we put in about 30,000 feet of underground line. 2 storage reservoirs, doing a great job for us. 2 tailwater recoveries, over a mile of linear storage on the deal. And then that's an example of one of the weirs that we put in at the bottom of the tailwaters. That's what we're using. We're not putting in riprap. We're getting a deal out of Texas Contact Designs weirs. They've been great.
How wide is that open?
You talking about the curved part?
Yes.
Probably 18 feet. That's a big ditch.
That's not a road on the side? Like
That's a pad up on the side. That's, yeah.
You don't get bad erosion around there?
Hadn't had a bit.
Better than a rock weir?
Oh, yeah. Yeah. I say it is. I hadn't had a rock weir. When we first started out, we wanted surface water, and we went in and just threw dirt in a ditch and put some Visqueen over the top of it and put some rocks on it and put a camelback in there, and we said, man, that's great. So that's when we decided to build this. It worked fine. We've had that about 8 years, and we have not had a lick of trouble out of it. It's been fine. All right, so here's where we are. Out of our place, about half of it can be irrigated with surface water. We're capturing 95% of the water that falls on our place. Kind of proud of that. You know, it's got to pass by one of those contact units to get off my place. We've got about 2,500 acres of farm fields and those catfish ponds that drain into us. And we stayed full during the drought, and we're working on the Sunflower River deal. And my total acres of farm ground went down deliberately because I wanted habitat for rabbits and deer and ducks, and I just deliberately took some stuff out of production that could have been in production, and so my total farmed acres went down. Our rents went up. I'm going to share my rents with you. I think that's the next slide. This is what we've done. This is my per acre rent, and that's just farm rent. Farm rent, they kind of track, but there's a lot fewer acres in cultivation. It's 1904 to start, and it's 1465 now that are actually in cultivation. That's not counting my pads within my landform fields. I'm 5% higher, I guess, in perimeter. But we started at $56 an acre, and we're at 200. Went as high as almost 250. You can see we went from crop share, cash to share, back to cash. That affects some of it. And we sandbagged a little bit when we went to cash, just because we think the markets are, we don't want to put anybody out of business. We like to keep our farmer.
So what was the difference again between the colored lines?
The top one is my gross farm revenue.
Oh, okay.
Yeah, that includes, I've got 221 acres of CRP in there now, that we've never had any of that before. This is my per acre cultivated acre.
I got you.
Yeah, so this is, more relevant. But I mean, we've almost quadrupled our rent, and the markets have been favorable.
More per acre on your non-cultivated.
Well, I'm making something on non-cultivated because some of it's in CRP. I'm about half CRP and about half I'm just growing it on my own, and I didn't put it in a program, just wanted to have flexibility on it. But the land, that we are farming and renting out, the markets have been favorable, obviously, and, farm rents have gone up generally, but they ain't gone up that much. And that's kind of going back to where we started. Why would you do this? One is the long-term perspective on stewardship. I think landowners are focused on stewardship in the long term. They can't afford to buy it again. They want to farm it sustainably, all the reasons NRCS would give you for wanting to have it. But the other thing is, if you produce, we haven't missed a crop. Anywhere that we're landformed and have water, we have not missed a crop. And I saw prior to that some really pretty crops come up and die, 100% die. And they would have happened this year, if you weren't set up for it. So a reliably produced crop with a higher yield and ease of use for the farmer, which we've been, I think, somewhat uniquely focused on. We're trying to build a farm that farms easy. It's allowed us to have some pretty good rents. We're really heavy black ground. I mean, we're as heavy. A friend of mine said about had a baby, and I said, "How's the baby?" He said, "He's really ugly, but we're dressing him up nice." That's my farm. We've got some heavy soil, so we've done our best. All right, now next. So, nothing's ever finished. It's like sweeping a dirt floor on a farm. Anybody knows that, right? You don't ever finish, you just decide that's enough for today. So we've made a lot of progress, but there's a lot more to do. And it seems to me an inevitability that the problems that I'm going to talk about here get solved with automation. I mean, I think all this is, there are a lot of things driving on-farm automation. Once you sort of set the table, how much time do I have? 5 minutes?
Yes.
All right, sorry. Once we set the table in this way, that you've got the infrastructure laid out, that you've got reservoirs and tailwaters and land formed and everything's in place, you're already seeing automation. You're seeing on and off on the wells. It's already there. NRCS cost shares on it now. You've got telemetry in moisture meters. You've got telemetry in flow meters. None of them are talking. The product I'm going to show you in a minute, that's the automated flashboard riser thing, we call it an auto riser. It has telemetry, all on different systems. But that's going to change. All we're really missing is an inbound water valve and then a platform for all of these things to sit on together where they can communicate, and you have a semi-autonomous irrigation management system that's going to take a lot of work off the farmer and give NRCS some data that they need. How do the reservoirs stay filled up? You saw that Camelback. That's a terrible setup, right? If you put more work on your farmer when you're finished with this, they're not going to use the system or they're not going to like it. It's contributing to labor costs. That's a rotten deal. How do they fulfill their purpose of settling out nutrients in topsoils in multiple rain events? I'll try to hit this one quick, but when you have a full pool and you get another rain behind it, the second rain flows right through the top and carries its whole nutrient and nitrogen load out the back and disturbs probably 50% of what was settled the first pass. So that's a problem. How can farmers release water slowly out of a wood board riser? There's 64 of them on my farm. Am I going to cut one board and come back 5 hours later and cut one? No. I'm going to get a chainsaw and go down to the bottom of the thing and rip every one of them simultaneously. That's what everybody does. And the guys that put the sensing equipment out there will tell you very quickly, they pick those nitrogen spikes up. They know when you cut your boards. It's negating the environmental benefit of a multi-billion-dollar investment. That's high on a list of priorities to fix within NRCS. If farmers are giving up acres, which we are, about 5% of everything you level will go to pads, maybe 7% with these new huge pads that they're mandating, reservoirs, tailwaters, taking on new costs to manage these systems, how do we calculate the real value of the improvements? You know, these are great improvements. They're all great. I'm glad I did it. I'm here to say that this is a good path to go down. But it's not without problems. And that's one of them right there. And if NRCS are going to spend millions of dollars to create these systems, then how are they going to get better at what they do or justify their budgets to somebody else? Maybe EPA, maybe somebody else would like to know. How are you really doing with all that money you're spending out there? There's no data. And one of NRCS's missions is to teach people how to do things better. Side inlet irrigation on rice, other things, there's no trick to it. It's just they know how to do something that the farmer didn't know how to do, and they're great at teaching it, and just one of the services they provide. If you get an automated system in place, they can directly participate in your irrigation management practices, which I think would be a good thing. This is a quick example of a fully automated system. That's an auto riser, which I'll show you. That's a well, that's a reservoir. These are your field outlets. If you were going to automate it, the moisture meter in this field would say, I've hit my number at time to water. So what happens? This riser, red top, opens up. These three close. The well turns on. Pressure sensors confirm that it's on. The water comes out in the correct field, and the riser at the bottom, the auto riser with a depth sensor, terminates the irrigation cycle. Semi-autonomous irrigation management system. That's coming. This is an auto riser. That's conceptual, and that's the first production unit. All it does is rotate 90 degrees. So it has sensors in it for water level. It has sensors in it for gate position. You can advance program it. If you're using it in a duck environment for moist soil or something, you could just time it to go down 1 inch a week for 16 weeks to do a moist soil management. Or you can flush rice, or you can catch short row water and back flood your long rows and then drop all the water. A lot of automation opportunities. In a tailwater recovery system, if the water is higher than the gate, there's a flood event. When they're even, it's stabilized. You wait the prescribed amount of time for settling to occur, and then you set the gate 1 inch lower than the water continuously till the water's out. Then you put the gate back up, and it's ready for the second rain event. So it's that sort of stuff that it's designed to do. All it does is rotate 90 degrees. This is a prototype in a test tank. All it does is rotate 90 degrees. The pipe, the drain pipe, is back here, would go through your levee, and this becomes your gate right there.
Did you develop this? You developed this?
I did. I built my first 10. We hadn't done anything. We're going to put them in the field, and we're going to let people look at them and tell us what they think. And if they like it, we'll commercialize it.
I like it.
All right. Next. All right. So it'll control water depth. It'll release water over the top only. That's the two key components of a traditional wood board riser. We're duplicating those things, but we're taking the work out of it. You don't have to wait out there and cut the boards, and don't have to do all that. It's not as you can do it from your cell phone. You can do it from you can pre-program it if you want to do it that way. It's got water level sensor, gate position sensor that's indexed, and you'll put in we're leaving 5 open slots in it for moisture meters, wells, flow meters, nutrients, turbidity sensors, cameras. We can plug up other stuff. We already have telemetry. So that gives us an opportunity. They're having to pull water samples, every 3 months to find out what's going on with the nutrients, and they're pulling them from the tailwaters, and there are multiple water sources for those tailwaters. This is catching in every pipe, and we'll have real time. It'll know when water's flowing, and it'll wait till it cleans the pipe, and it'll pull a sample every time. So that's an example of it. So the telemetry simplifies things for the farmer, takes some workload off of them, and creates a data stream for NRCS. Okay, so you're going to make better crops. If you can manage your water better, I think it's fair to say you make a bigger crop. You're definitely going to save on labor and energy and material. You can have information flow the other way, especially once these things integrate into one system. You can have the PhD agronomist at Mississippi State give you a little trick about irrigating you don't know. They love to do that, and this will give them a way to do it without having to come to your farm to do it. And it'll become part of these larger systems. Environmentally, the weak link in the whole deal, all the reservoirs, the tailwaters, the pads and pipe, everything that's going on with NRCS right now, huge amount of investment, is being fundamentally negated by that chainsaw in the back of the pipe thing, where the farmers are just cutting all the boards. It's messing the whole system up. So if this is set to set the gate 1 inch lower than the water continuously, that'll fix that problem. It's going to reduce your water use during the growing season. NRCS pays a lot of people to hold water in the winter. Nobody does it. They have no way to check compliance. They'll have to do it. If they're going to get paid to do it, they'll have to do it. So that allows them to do it. And then real-time, site-specific data regarding water quality and use practices. That's it. Thank you. I think I used my time. Thank you.
If anybody has any questions, we're actually right on time.
Another-
Pretty good for haven't ever done
Total
this
accident.
together.
Days a week do you spend it in NRCS?
Not many. I really don't. We've got a good office, and they're not all good. I own land in central Mississippi. I do development work in Florida. I've got, I'm exposed to other NRCS offices, and they're not all good. And that's the downside. You probably won't build a reservoir or a tailwater without their help. It's expensive. The one that in my county, Sunflower County, is really well run. They're farmer friendly, they understand the issues, and they're trying to get all the budget they can get. But to answer your question, it's not been a huge amount of time for
The
me.
latest thing with Trust Unlimited, where they give you this money to hold flood on your rice fields all over. Y'all get in on that?
I hadn't done it, I'm familiar with it, but I hadn't done it.
And there was part of it supposed to be for construction.
Well, the CSP, Conservation Stewardship Program, does require that you impound water in the winter, and it's really to recharge the aquifer, but it's for waterfowl also.
Right.
That's the thing that nobody's doing.
This new one, we had 3-day warning. In
Oh, yeah.
Arkansas to sign up to the program. And then after they started implementing it, well, it didn't even We did it to try to get some more tailwater still. Well, they'll pay you $40 an hour to hold the flood all winter, which we're doing already. So you gotta have some kind of way to document, monitor your water coming out. Nobody has that yet.
That website doesn't work, but it will eventually, so write that down.
Are those basins dead level, those 4 basins that you had there?
Oh, you mean the 4 fields that were connected in that
Yeah, your
system?
schematic
We're putting 1.5 on everything. It's running 1.8 inches of fall every running 100 feet in a field, which works for us. It gets the water off, and we can grow cotton. It's just enough to get it off for cotton and corn, but it's just slow enough we can still grow rice. It's kind of that twinger number. 1.5 is what we've done everything on.
Have you monitored the water quality? Continuously monitor the water quality?
Yeah,
For the nitrogen and phosphorus?
for nitrogen and turbidity, that's the sort of the add-on product for us. We're really in conceptual stage on that part of it. It's a plug-and-play thing for us. We can buy the sensors and we have the slots available to plug them in. It'll work, but we're not leading off with that product. Yeah. We've built, I guess, 10 of these. We've got them. There's actually a facility in Memphis, a really robotically built 1,381,000 square feet under roof metal facility, and then a automation company out of North Georgia that specializes really in remote oxygen sensing for catfish ponds. That's doing the automation side of it, and they built a really pretty product. We just got our first 10. We're going to put them out and try to get DU and get Mississippi Wildlife Fisheries or some big rice farmer, and we're just going to put them out there and say, well, what do you think? If this makes sense, good. And that's where we are. So we're not, and it's kind of been done sort of as a side project because I saw a need for it on my phone.
I have a question about your presentation that phosphorus is relatively lower than the nitrogen. And it means that maybe the phosphorus attached with the sediment and sitting down.
Yeah, I mean, that's
And maybe
what we've been seeing, and you're right, it's following the same trends as the sediment, so we think it is settling out some, and you can tell, actually, our Knoxville County site, they grew up farming in the Midwest and have come south, and so they like to do a fall application of poultry litter, and you can see it washing right off, and the concentrations decrease with every subsequent storm event you get, but it's all being captured by the ponds.
so down the road you may be expecting the nutrient recycling effect when once you do the tailwater recovery system, maybe putting back the more nutrient in your field.
Right, we're trying to get a better handle on those numbers. Like I said, we've got the 2 samples from East Mississippi, but what does that look like in the Delta with a pond that's not as deep?